roundup of RAPID plus TCT 2021, where over 270 companies exhibited the solutions that address your additive manufacturing needs. For 30 years now, SME has been doing just that with this event. I'm Todd Grimm, an advisor for the event and president of TA Grimm & Associates, an additive manufacturing, consulting, and communications company. I'll try my best to capture the feel of the event, the activities on the agenda, and the solutions I discovered while on the show floor. But note, I won't be redundant. The things we knew in advance, like those from Azul 3D, Inkbit, Stratasys, and others, won't be covered because they were in my preview video. If you're interested, you can take a look at that video at the link down here at the bottom of the screen. Now, it's been 10 days since the event ended, but I'm still digging out from under a mountain of news and information. And I'm still digesting all that I learned, discovered, and was told. I'm also regretting all the things I did not see, even though I was there from 8 in the morning to close every single day. Smaller show due to COVID? Yes, and that was intentional. Worth my time? Absolutely. Before I get to the news and highlights, I want to recap the overall event. Most notable was the level of participation by attendees, exhibitors, and speakers. And according to SME, the attendance numbers far exceeded expectations. Those that joined us brought vibrancy. You could feel it in the air. Enthusiasm, smiles, eagerness of the attendees, and a sense of all of us in it together, showing resilience and a strong sense of community. Exhibitors could measure it by the quality of those that roamed the show floor. Everyone I spoke to agreed that the numbers were lower this year, but the quality was higher. Attendees engaged in purposeful conversations with the intent to find solutions. They weren't kicking tires. They were there to address real business needs and to get answers. So kudos, or a tip of the hat, to all for making RAPID plus TCT a success. Complementing the show floor was a strong program of content recognition and interaction. Free to all, up on the main stage were 3 keynotes delivered by Melissa Orm of Boeing, Terry Wohlers of Wohlers Associates, and Mark Guida of Mayo Clinic. Also free on the main stage were 11 thought leadership panel discussions. And for paid conference attendees, 68 conference sessions organized in 3 content pillars: evaluation, adoption, and optimization, plus another 14 sessions in the medical track. So there was an absolute ton of great content at the event. There were also many other engaging activities, including an awards ceremony. The winning entry in the Digital Manufacturing Challenge was rapid deployment of patient-specific prosthetic assemblies in emergency medicine. This work was done by Sagar Patel and Martine McGregor of the University of Waterloo. For the Aubin AM Case Study Award, which recognizes innovations and applications of AM technologies, a large team represented by DM3D Technologies, NASA Marshall Space Flight Center, and NASA Ames Research Center was announced as the winner with its entry, Rapid Large-Scale Additive Manufacturing of a Full-Scale RS-25 Engine Nozzle Liner. The Industry Achievement Award went to David Lee, who's CTO at 3D Systems. And that was a well-deserved award or honor. He has a storied history all the way back to the early research of selective laser sintering, then a field technician for that technology, then on to developing his own service bureau, and ultimately culminating in chief technical officer. And he earns that award for all that he's contributed in terms of technology development, application development, and community building. Now, ignoring the show floor, that right there was too much ground to cover in 3 days. I and all others had to wisely pick and choose where we spent our time. So now, let's move on to new products, software, and materials that were on display at RAPID plus TCT. As expected, there was a fair amount of breaking news during the event. Boston Microfabrication announced a new printer using its projection microstereolithography technology. This company is going after production applications and attacking the realm of micromolding and micromachining. The MicroArch 230 is the latest in its line of 2-micron resolution printers. Versus its predecessor, it offers 5 times the build height with a build volume of 50 by 50 by 50 millimeters and 5 times the build speed. The company also announced 3 new materials: 2 ceramics, alumina and magnesium titanate, and a solderable high-temperature, high-strength resin. In my pre-event video, I speculated that Massivet may formally announce its Massivet 10,000, and they did just that. They demonstrated it right alongside the Massivet 5000, which I discussed in the previous video. The 10,000 will be coming out in 2022, and it's using a process they're calling cast in motion. It's a hybrid process. It combines the gel dispensing printing of the 5000 with another operation, which is deposition of a thermosetting polymer. That thermosetting polymer has high heat deflection temperature and low coefficient of thermal expansion. So gel dispensing printing creates, in essence, a mold, and then this polymer is deposited in the cavity of that mold. When the process is done, the photopolymer is dissolved away, leaving you with this polymer part as a tool. With high heat deflection temperature, low CT, you guessed it, they're considering tooling applications for composite layups. Sinterit announced and demonstrated the NILS 480 polymer laser sintering printer. NILS stands for New Industrial Laser Sintering. This machine will start shipping in January for the low price of $60,000. It offers a build volume of 200 by 200 by 330 millimeters and something a bit unique, continuous printing. So the build chamber is presented for the build. Once that's complete, it's shifted over to the left of the machine for cooling. Meanwhile, printing can continue when another build chamber is raised into the print area. And with laser sintering of polymers, you know it's all about managing the thermal profiles. And what they described to me sounded pretty good. I think we can trust it, but it's up to you to test it to see if it'll produce the parts of the quality that you're looking for. Also interesting that they led the conversation with polypropylene, a polymer that has been growing in adoption in additive manufacturing over the last couple of years. Farsoon announced a new mid-range metal printer, the FS273M, which is the successor to the FS271M. The 273 offers either one or two lasers, 500 watts, and a build volume of 275 by 275 by 355 millimeters. Versus the 271, it adds new recoder design, truly open parameter sets, integrated filtration system, preheatable base plate, removable airflow container, and a large powder supply chamber. Stratus has had a number of announcements in its press release, but I'm going to focus on those related to materials. For its Origin 1, it announced two new materials developed in collaboration with Henkel. First off, Dura 56, which was used to make the kick scooter shown in the video that I ran. This material is for durability and impact resistance, and for parts with a Class A surface. The second material is called Loctite 3D IND 405 Clear. It can produce parts that are optically clear with a bit of polishing after the print operation is done. And it also announced the Origin Open Material License, which can be used by advanced users and material companies to develop, test, and experiment with custom workflows and new materials. It allows overrides on a layer-by-layer basis of light, temperature, force, velocity, and pressure to truly take control of the entire process. For the H350 with a SAF process, they announced availability in 2022 of PA12 or Nylon 12. The machine was initially launched with PA11, the bio-based polyamide. Like Stratasys, Dendrite had a number of announcements in its press release, all related to partnerships or collaborations, naming Impossible Objects, DNA.am, and the one I'll elaborate on, ZAR and Meteor Inkjet. Together, they plan to advance binder jetting by hooking together Dendrite's accelerated computation engine, ZAR's printhead technology, and Meteor's drive electronics and digital front end. A lot of trends were visible at RAPID TCT, but the one I celebrate the most and was most prolific is the collaborations. Working together will advance the technologies and applications faster, or at least far faster than if we choose to work alone. Now moving into materials, 6K Additive announced new refractory materials for powder-based additive manufacturing processes. These include tungsten, rhenium, and niobium-based powders used for defense, aerospace, and medical applications where material properties such as high temperature and high strength are desired. By the way, the part that was shown was made of the tungsten-rhenium material blend on a concept laser MLab printer. That part was for Quadris. In the booth, 6K Additive also listed other refractories which are in development and could launch soon. Teethon 3D and McNano dropped some material news on the first day of the show. Now, Teethon 3D, you may know them for DLP printers and also materials with a heavy emphasis on ceramics. McNano, you probably don't know much about. They offer an additive, essentially, for additive manufacturing materials that delivers discrete carbon nanotubes. Now, the announcement was for a material called Sea-Light ESD resin, offering high temperature operation up to 225 degrees C, and as ESD indicates, parts with ESD properties, electrostatic dissipative. And get this, from concept to market, they completed that project in just 6 weeks. Next up is the news from Covestro and Paramatters. They announced anisotropic optimization software. Paramatters brings generative design knowledge to the collaboration. Covestro brings its material and AM process knowledge. Paramatters has offered CogniCAD for generative design for several years, but the analysis, simulation, and resulting design operate in the context of isotropic properties. Now it considers anisotropism in the XY plane to redirect the toolpath, region by region, to yield the desired mechanical properties while minimizing material used and time to print. But there are two things to note. First, you need to expect to populate your own data sets to feed the simulation. Populate that by building parts in multiple orientations, doing some testing to find those properties, put that in the data set. Second, the output of this process is G-code. So to use it, your printer has to be able to import G-code to drive the 3D printer. But note that Paramatters is interested in working with printer manufacturers that can't currently accept G-code as input. So if this sounds interesting to you, maybe speak to your supplier to let them know that this is something that you really, really want. Anisotropic optimization software is now in the beta test phase. Continuing on with software, Markforged announced Eiger Fleet. In its announcement, it said that this is a cloud-based application to accelerate adoption at scale. Well, what does that mean? Well, it's about taking a pilot production to large-scale, globally connected, distributed manufacturing. So Eiger Fleet offers a centralized source of visibility and control to all of your Markforged systems, and it integrates with your enterprise-level software applications. Let's add to that breaking news, solutions that have been previously announced, but were fantastic to see and discuss in person. And I have 3 examples to show the value of face-to-face discovery. The first example, Hyperion Metals with the GSD process. I gave the rundown of what they're doing to deliver titanium powder in a different way in the previous video. But what I overlooked until I stood there in the booth is the claim that they can supply titanium for the price of stainless steel. The GSD process, which is granulation, sintering, and deoxygenation, plays a big role in lowering cost, but it sure helps that Hyperion Metals is an ore-to-powder company with its own U.S. titanium mine. AmFlow is my second example. I walked past them several times. Just did not catch my attention, but a colleague suggested I spend some time in their booth, and I'm glad I did. They're offering a straightforward solution to AM part handling that replaces the human touch through automation. Their solution combines a vision system with conveyance. Using photogrammetry, parts are identified in 0.2 seconds and then conveyed to the appropriate station for the next step in that part's process, be it post-processing, inspection, or shipping. That workflow information can be fed to or pulled from your ERP system via APIs. Now, the company suggests that this is a justifiable solution when you handle more than 200 parts per day. The last example of face-to-face value happened in the 3Dgens booth. Yet again, a colleague suggested I check them out. My initial thought was, ugh, another FFF option. That turned to them having my full attention when they described what they'd done to address the needs for production-oriented printing. On hand, they had the F350 and F421. These are nearly identical machines differentiated by chamber temperature and build volume. The F421 being the larger, with 380 by 380 by 420 millimeter build volume, and hotter, with a chamber temperature up to 180 degrees C. They're claiming print speeds of 400 millimeters per second. That's not travel speeds, that's print speeds. And offering features to support production such as sensors for closed-loop linear encoders and filament issue detection. The printers are also outfitted with modules for the extruders, modules for the various nozzle temperatures needed for the materials you're running. And these can be easily swapped without tools. And there's more to these machines, all with an angle of fair pricing while matching performance needs for production. The F421, for example, sells for $85,000. As I strolled the floor, I stumbled on Fabricate Labs, which is using a unique process. It's essentially electroplating in 3D. To oversimplify, it's kind of like DLP, but instead of LEDs and light, they're using a thin film transistor, TFT, that's pulling current to the desired pixel or voxel where solidification is desired. Now, as you saw in the image, some small parts, but with high resolution and great definition. Presently, they're thinking of applications for semiconductor, electronics, medical, and RF components. Fabricate Labs is planning for a 2022 release of an R&D printer. And next up, Fortify with its digital composite manufacturing. I believe this was the first time it had its printers at a show. Its process is based on DLP, but with a couple of big twists. First is continuous kinetic mixing. What this does is mix fillers or other additives with the photopolymer continuously as the process is being completed. And when combined with its high downward force, essentially squeezing the resin from between the part and the glass from which the light shines through, you can process high viscosity materials. The second twist is flux print. They're using a magnetic field to orient fibers for improved properties. One example was a part they showed me that was opaque when the fibers were aligned in the XY plane. But when those fibers were stood up in the Z-axis, it became somewhat transparent. And they have software called Flux Developer, which provides an open platform for development of new formulations. Interested in color? With high color fidelity on your desktop, Mimaki may have the solution for you. It showed its 3D UJ2207 UV-LED printer. Whew, that's a mouthful. Which sells for $40,000. It shares much in common with its big brother, including ICC profiling, but with a smaller footprint and smaller build volume. That build volume being 200 by 200 by 76 millimeters. For those I didn't mention, my apologies. I simply did not have enough time to stop by every single booth. And even with that, I've only scraped the surface on what I saw. But I hope that this recap helps you as you navigate to find the AM solutions that you're looking for. It was the 30th anniversary for RAPID TCT. Now, the traditional wedding gift for 30 years is the pearl. And as I said from the stage, it is the perfect metaphor for the event and for additive manufacturing, taking a long time to develop, but in the end being a thing of beauty. It's also a great metaphor for what each of us needs to do. Dive deep to find the pearls. It's easy to acquire information that only scratches the surface, but to identify and vet the best solutions for your applications, you need to dive in or dig in deep to find the facts appropriate to your needs and your situation. So dive in and keep exploring. Additive manufacturing is an ongoing journey of discovery. Once again, hats off to all. SME, Rapid News Group, exhibitors, speakers, advisors, and attendees for making this a great event, in spite of the challenges. Now, in only 8 months, we get to do it all again. Mark your calendars for the next RAPID TCT, which will be held May 17th to 19th, 2022 in Detroit, Michigan. I look forward to seeing you there, if not beforehand.